Good day and welcome to this video of engineering maths. In the next few minutes, I'll be solving this separation of variable method. They are very easy and you have to be fast in it when you are in an exam or a test. So briefly, the secret behind it is that we separate y variables to x variables. So you can put y variables at the left and x variables at the right. Then you integrate both sides and isolate y. So do you get? So now briefly, we're going to be looking at this one. Dy dx equals to x and y. This is just a basic one. What do? Let y come to this side and let x, everything that has x, come to this side. So what are we saying? If you do that, that means this is dy dx and dy dx equals to x y. So if this y come here, it will be divided by, so you have dy over y, and if this dx come here, it will be x dx. So what am I saying? You have dy over y is equals to x dx. Now you can also write this as 1 over y dy equals to x dx. Now what do you do from here? You can integrate both sides. So if you integrate both sides from here, what are you going to be having? If you integrate 1 over y, that will be ln y. Then if you integrate x, you know when you integrate, it will be plus 1 of the power, then divided by that power. So you'll be having x raised to power, there's a power of 1 here before, that will be 2 over 2 plus c. Note that the x is taking the constant, not y. Just like in implicit variation, y always have dy dx after it when you differentiate with respect to y. But here now, we are dealing with x and y. But x will take the constant, not y. Do we get? So that's how we have this. So ln y equals to 1 over 2x over 2 plus c. You can also write it as ln y equals to 1 over 2x squared plus c. Still the same thing. Now quickly, let's move to the second one, the quick one. Now we want to do the same thing. We want to separate y from x. Now we have dy and we have root y. We can just do cross multiplication here. So if you cross multiply, you'll be having dy root y equals to x dx. Dy root y is equals to x dx. And what is root y? Root y is y raised to power half. It is y raised to power half. So if you are going to solve that, you can just write dy y raised to power 1 over 2 equals to x dx. And from there, you can integrate both sides as usual. Integrate both sides. You'll be having, if you integrate this, that will be y raised to power 1 over 2. You add 1 to the power, and when you add 1 to the power of that will be 3 over 2. So you'll be having y raised to power 3 over 2 over 3 over 2 is equals to x. This should be x squared. It will turn to x squared over 2 plus c. Remember I told you this, x always carry c. So from here you can multiply both sides by this, because our plan is to isolate y, right? So we want to make this y alone. So we can multiply both sides by 3 over 2. If you multiply both sides 3 over 2, we cancel 3 over 2 here. We have this y raised to power 3 over 2 equals to, then you can say 3 over 2 multiplied by this now, x squared over 2. So plus c, don't forget that. So here we'll be having this, then 3x squared over 4 plus c. You can also say y raised to power 3 over 2, 3 over 4 x squared plus c. It doesn't stop there. You want to isolate y, right? Y is the main function that must be alone. So this power, if it is coming here, it will flip. You know, this is carrying the root of 2 and the square of 3. If it comes here, it's going to be carrying the root of 3 and the square of 2. So what am I saying? You'll be having y equals to 3 over 4 x squared plus c. Then it will now be 2 over 3 in this place. 2 over 3 in this place. So that's just for that one. Now look at this. We're having dy dx x squared over y raised to power 3. You can just do cross multiply here also. So we're having y cubed dy equals to x square dx. Note that this will give us what y of x is for. This is x and this is what y is. So now when we get there, we are going to insert it. Now we can integrate both sides as usual. Integrate both sides. If we integrate this, that will be y raised to power 4 over 4, and here will be x raised to power 3 over 3 plus c. Right? Now you can rewrite this function. You can rewrite this function to be 1 over 4 y raised to power 4 equals to 1 over 3 x cubed plus c. So after that, what we are going to be doing is to make y subject to the formula y raised to power 4. We want to isolate this y. And what are you going to be doing? Divide both sides by 1 over 4. So when you want to continue from here, we divide both sides by 1 over 4. When you divide both sides by 1 over 4, you'll be having something like this. Let's just say this will cancel this. It will remain y raised to power 4 rather equals to 1 over 3. No, this is multiplication. When this is division, when it turns to multiplication, it will be 4 over 1 here. So 4 over 1 x cubed plus c. Now it will be y over 4 equals to 4 over 3 s cubed plus c. Now what's our next step from here? We are targeting that constant and we have been given x and y. We are targeting that constant and we are given x and y. So what are we going to do? Let's input the values so that we can get our x and y. So what is y? Y is 2, right? Y is 2 and x is what? 1. So when we insert it here, it's going to be 2 raised to power 4. You know y is 2. 2 raised to power 4, that would be 16 equals to 4 over 3. What is x? X is 1 raised to power 3 plus c. So c will be what? It will be 16 minus 4 over 3. 16 minus 4 over 3. So because this one is raised to power 3, it's going to be 1. Then multiplied by this, it's going to give you 16 over 4 over 3. And what will that give us? That will be 44 over 3. So it is 44 over 3. That's our c. So when you want to rewrite that equation, you just say your y now will be equals to, it is 4 raised to power 4 here. When it comes here, it's going to become the inverse of that 4. So you'll be having raised to power 1 over 4 on the other side. So let me just finish solving it here. Continuation of what is here from here. We will now say y equals to 4 over 3 x squared s cubed plus c raised to power 1 over 4. So now you can now input your c. What's your c? 4 over 3 x plus 44 over 3 raised to power 1 over 4. That's it for that. We're going to continue on the next page of this question. On this separation of variables. Now let's do what we usually do here. We're going to put the variables on a different side, collect like terms. So you have y here as multiplication. If it comes here, it's going to be 1 over y dy. 1 over y dy. So we have dy over y, and here this one will come here. It's division here before, so if it comes here, it's going to be multiplication. So we have cos x dx. So you can rewrite this as 1 over y dy equals to cos x dx. So integrate both sides. When you integrate both sides, you have ln y equals to when you integrate cos, it's going to give us sine. So we have sine x plus c. That's just it. This one is not, it's very simple. So now here we multiply, we cross multiply here. So we'll be having y squared dy, and on the right side we'll be having 6x dx. Right? So integrate both sides as usual. Here too they gave us limit, so we are targeting the constant. Now this will be y raised to power 3 over 3. Then here we'll be having 6x raised to power 2 over 2 plus c. Remember, x is always taking the constant. Now this one we want to isolate y here, but we can still simplify this further. We just say y squared over 3 equals to 6 divided by 2, that will be 3x raised to power 2 plus c. Now we want to make y isolate y, so that will be multiply both sides by 3. You'll be having y cubed equals to, when you multiply 3 here, that will be 9 x squared plus c. We don't multiply with the constant. It's negligible. We don't multiply with the constant. So we can now insert our x and y. Remember I said this is x and this is y. So what is y? Y is 3. So we have 3 cubed, that's 27, equals to 9 into our x is 0. So I don't think anything will happen here. All this will be equals to 0. So that means plus c. So that means c is 27. Now we can now rewrite this. We want to isolate y, remember. So this cube will come here and become 1 over 3, raised to power 1 over 3. So we're having y is equals to 9x squared plus c all raised to power 1 over 3. Now insert the constant, it will be y equals to 9x squared plus the constant, which is now 27 that we've calculated, raised to power 1 over 3. So that's just that. We're going to be solving the last question. So we are separating x and y as we normally do. So here now we are having x y raised to power minus 2. If this y come here, it will be y raised to power 2 because inverse will change to normal. So we have the y raised to power 2 equals to, then we have minus x dx on this piece. No, it's division that is making it here. So if it comes here, it's going to be multiplication. So here we can integrate both sides from here. Integrating both sides, we are going to be having on this side y cubed over 3, then we are going to be having minus x raised to power 2 over 2 plus c. Now we can isolate, we can express the equation further. The expression, we are going to be having 1 over 3 y raised to power 3 then equals to x squared over 2 plus c. We can also see that one to be 1 over 2 x squared, still the same thing. So we want to isolate y, we are going to divide both sides by 1 over 3. So when we do that here, 1 over 3 we cancel 1 over 3, we have y cubed equals to, then here we'll be having minus x squared over 2 divided by 1 over 3. You know we are dividing both sides. So now it will be y cubed equals to minus 1 over 2 multiplied by, this 3 will come up because they are terms multiplication. So we'll be having x squared. You know, I brought this 1 over 2 outside and I brought the x squared. So there's no big deal there. So that will be y cubed minus 3 over 2 x squared plus c. Now, what's this 3 going to do? It's going to come to this place and turn to the root of this. You know, it's going to be the cube root of this, like that. Just as saying cube root both sides. So you're going to be saying y equals to minus 3 over 2x squared plus c, all bracket 1 over 3. It's going to be the inverse here. So that's all for this video. Thank you very much. Like, share, subscribe and comment. We're going to be doing more of differential equation. Thank you very much.